Here is another topic, solution of differential equations using Laplace transform. This is another method of solving differential equations. Okay, the advantage of this method is that you're not going to use calculus here, but differential equations, specifically linear differential equations, can be solved only using some algebra manipulations. Now, if f of t is defined, okay, for all values of t greater than 0, and s is a real number, such that f of s equals the integral from 0 to infinity of e to the minus st f of t dt, and converges for some finite value of s, then we say that the Laplace transform of f of t is equal to f of s. So f of s is the Laplace transform. The symbol L stands for Laplace transform. Now here is a table of the basic Laplace transforms. Okay, let's take a look at it one by one. For 1, the Laplace is 1 over s. For t, the Laplace is 1 over s squared. For t to the n, generally, the Laplace transform is n factorial over s to the n plus 1. For e to the at, the Laplace is 1 over s minus a. For cosine at, the Laplace is s over s squared plus a squared. For sine at, the Laplace is a over s squared plus a squared. Take a look at the difference. For cosine, the numerator is s. For sine, the numerator is the constant a. Now, similarly, for hyperbolic cosine at, you have s over s squared minus a squared. For hyperbolic sine at, you have a over s squared minus a squared. And for a f of t plus b of g of t, where we have a and b are constants here, okay, the Laplace transform is a L of f of t plus b L of g of t. This is actually, you can distribute the L, okay. So this is the linearity property. Let's have some examples. Okay, the Laplace transform of 1 is 1 over s. It's here. The Laplace transform of 2 is 2 over s. Obviously, 2 is just what? 2 times 1. So therefore, the Laplace transform of 2 is 2 over s. The Laplace transform of t is here. 1 over s squared is here. The Laplace transform of e to the 4th is here, where n is 4. So if n is 4, here we have simply what? 4 factorial over s to the 5. That's 24 over s to the 5. The Laplace transform of e to the 4t, look at this formula, that's 1 over s minus a. So it's simply what? 1 over s minus 4. The Laplace transform of e to the minus 7t. Okay, look at this. This is s minus 7, or s plus 7. It's the Laplace of e to the minus 7t. The Laplace transform of sine 4t. Look at this formula here, there. That is a over s squared. So this plus a squared, that's 4 over s squared plus 16. The Laplace transform of cosine 3t is what? Is s over s squared plus 9 is here. The Laplace transform of hyperbolic sine 4t, this one, that's 4 over s squared minus 16. That's s squared minus 4 squared. The Laplace transform of hyperbolic cosine 60 here is s over s squared minus 6 squared, or minus 36. Okay. Alright, let's get now the inverse Laplace transform. Okay. Now, remember that if Laplace transform of f of t is equal to f of s, then f of t will now be equal to the inverse of, okay, inverse of f of s. So this one is the rule. Okay. Now these are the formulas. Okay. So here 1 over s, the inverse is 1. 1 over s squared, the inverse is t. 1 over s to the n plus 1, the inverse is t to the n over n factorial. 1 over s minus a to the n plus 1. Now you just introduce e to the at. This is similar here. T to the n over n factorial. S over s squared plus a squared. The inverse is cosine at. Now this is not a but 1. This is 1 over s squared plus a squared. The inverse is 1 over a sine at. 1 over s minus a squared plus b squared. The inverse is 1 over b e to the at sine bt. S over s minus a squared plus b squared. The inverse is e to the at cosine bt. 1 over s squared plus a squared squared. The inverse is 1 over 2a cubed sine at minus at cosine bt. S over s squared plus a squared squared. The inverse is t over 2a sine at. Now let's have the first example. Inverse of 1 over s is obviously 1 from here. Inverse of 1 over s plus 3. Okay, actually we have another formula. Okay, if we have 1 over s minus a, the inverse will be e to the at. So here inverse of 1 over s plus 3, this is the same as 1 over s minus 3. That's the same as e to the negative 3t. Inverse of 1 over s to the 5, we can use this formula here where our n is 4. This is the same as what? 4 plus 1. So inverse of 1 over s to the 5 is t to the 4th over 4 factorial. That is t to the 4th over 24. Next, inverse of 1 over s squared plus 9. Okay, where do we have this here? The inverse is 1 over, remember the square root of 9 here is 3. So 1 over 3 sine 3t. Next is inverse of s over s squared plus 16. 16 is 4 square. Here, we have it here. It's cosine of 40. Inverse of 1 over s minus 3 squared plus 4. Now, look at that s minus 3. You introduce an e to the 3t. Where do you have it? This one. And then, where do you get that 1/2? That is 1 over b. That is the square root of 4. 1/2 e to the 3t, and then sine of 2t. So, this, remember, 4 is 2 squared. Inverse of 2s plus 1 over s to the 4th. This can be written as inverse of 2 over s cubed. That's 2s over s to the 4th. That's 2 over s cubed plus inverse of 1 over s to the 4th. This is 2. This is s cubed. That is t squared over 2 factorial plus what? T cubed over 3 factorial. 2 divided by 2 factorial, that is 1. So this is t squared plus t cubed over 6. Next, inverse of 3 over s plus 1 to the 5th. So you can have it here. So this is the same as 3 to the negative t, and then t to the 4th. That is this, remember, 5 is 4 plus 1. T to the 4th over 4 factorial. This is the same as 3 over 3 divided by 4 factorial. 4 factorial is 24. 3 divided by 24 is what? 3 divided by 24. This should have been what? This should have been 1 over 8. 1 over 8. This is 1 over 8 e to the negative t to the 4th. Next. Okay, inverse of 1 over s squared plus 9 squared. Okay, where do you have this? This one. Our a here is what? Our a here is 3. The square root of 9. So that's 2 times 3 cubed. 1 over 2 times 3 cubed. Sine 3t, that is sine 80 minus 80, that is 3t cosine 3t, 2 times 27, that's 1 over 54 sine 3t minus 3t cosine 3t. Okay, and one more example, inverse of s over s squared plus 16 squared. It's here, our a is what? Our a is 4, so 2 times 4 is 8, therefore this is t over 8 sine 4t. Okay, let's have the Laplace transform of derivatives now. Now this is a formula for the first derivative. Okay, Laplace of y prime t is SL of y minus y of 0. Laplace of y double prime t is s squared L of y minus sy of 0 minus y prime of 0. L of y triple prime t is s cubed L of y minus s squared y of 0 minus sy prime of 0 minus y double prime of 0. Now you notice that there is a pattern here. Look at the y triple prime. Okay, all of them has or have ly's, and then this is s cubed. Okay, descending power s cubed, s squared, s, and s to the 0, where all the first element is positive and all of this is negative, while your y of 0 is in ascending order of differentiation. Okay, from y of 0 to y prime of 0 to y double prime of 0. Look at ly double prime, that is s squared L of y minus sy of 0 minus y prime of 0, that is descending s squared, descending powers of s. So s squared, s, and y, s to the 0, and as well as what? Ascending order of differentiation for y of 0. So y of 0 and y prime of 0, all of these are negative, and then here are all positive with all have L of y. Let's have one example. Let's have y prime plus 2y is equal to t, y of 0 is 2. That means when t is 0, y is 2. The solution is get the Laplace transform of both sides. That gives you L of y prime plus 2y is L of e to the t. Distribute the L, okay, using linearity property, that is L of y prime plus 2L of y equals L of e to the t. And notice our formula here for L of y prime. So your L of y prime is what? SL of y minus y of 0 plus 2L of y is 1 over s minus 1. That's the Laplace of e to the t is 1 over s minus 1. And we know y of 0. What is y of 0? Our y of 0 is 2. So therefore this is what? 2. Then substitute, okay, SL of y minus 2 plus 2L of y is 1 over s minus 1. Combine this SL of y and 2L of y, you'll get what? Okay, factor the L of y, you'll get s plus 2L of y, and then transfer the 2 to the right, that is 1 over s minus 1 plus 2. Then combine this right side here. Okay, the LCD is s minus 1, so s minus 1, okay, divided by s minus 1 times 1, that is 1. S minus 1 divided by 1 times 2, that is 2 times s minus 1. Combine this, you have what? This is 1 plus 2s minus 2, that is the same as 2s minus 1. So 1 minus 2 is negative 1 over s minus 1. Divide both sides by s plus 2, that gives you L of y is 2s minus 1 over s minus 1 times s plus 2. Now you will have to invert to get the value of y. That's the inverse of 2s minus 1 over s minus 1 times s plus 2. Now remember, you will have to break this into partial fractions. Now these are all what? These are The denominator are both linear, so the numerator of the partial fractions must be constants. So 2s minus 1 over s minus 1 times s plus 2 is a over s minus 1 plus b over s plus 2. Okay, combine. So this one is s minus 1 s plus 2. This is a times s plus 2 plus b times s minus 1. Or 2s minus 1 is a times s plus 2 plus b times s minus 1. Now, how do you get a? Just substitute what? Just substitute s is what? S is here. Just substitute s is 1. If you substitute s is 1, okay, you'll get the value of a. Okay, your a is 1/3. Okay, that is 2. 2 minus 1 is 1 is equal to, alright, here is what? This will be eliminated. This is 1 plus 2, this is 3. So this is 3a. 3a. So therefore your a is 1/3. And to get the value of b, substitute what? Substitute s is -2. So this will be eliminated there. This will be eliminated, and 2 times -2 minus 1, that is what? -5. -5 is equal to what? Okay, this is, you are supposed to substitute s is -2. So -2 minus 1 is -3. So this will be what? This will be b times what? -3. And then you get b is 5/3. Therefore, your partial fraction is what? Okay, 2s minus 1 over s minus 1 times s plus 2 is a over s minus 1 plus b over s plus 2. And we know the value of a already. That's 1/3 over s minus 1 plus 5/3 over s plus 2. Next is you get the inverse here. Go back here. Now remember that we now have the inverse of what? We now have the inverse of this. This one should be what? Should be inverted. There. That's why you have this one. Inverse of 1/3 over s minus 1 plus 5/3 over s plus 2. Now the inverse can be what? Can be alright, can be applied linearly here. So what is the inverse of 1/3 over s minus 1? This is what? This is 1/3. Okay, this is 1/3 e to the t. And then what about here? The inverse of this is 5/3 e to the -2t. Okay, remember that the inverse of 1 over s minus a equals e to the 80. Alright, e to the 80, and therefore our answer, or our particular solution, is what? Is y is 1/3 e to the t plus 5/3 e to the -2t. Okay, let's have this next example. Let's have y double prime plus 4y is cosine 2t, y of 0 is 0, and y prime of 0 is 0. Okay, what is the meaning of that? This means that when t is 0, y is 0, and y prime equals 0. So next step is get the Laplace transform of both sides. So you have what? You have Laplace of y double prime plus 4y is Laplace of cosine 2t. And substitute the formula for Laplace of y double prime. Okay, now get the Laplace first individually. This is Laplace of 4 y double prime plus 4 Laplace of y is Laplace of cosine 2t. Now what is the formula for Laplace of y double prime? That is s squared L of y minus sy of 0 minus y prime of 0 plus 4 times the Laplace of y. The Laplace of cosine 2t is s over s squared plus 4. Now remember that our y of 0 is what? 0, and your y prime of 0 is 0. So therefore you simply have what? Okay, substitute this is s squared L of y minus s times 0 minus 0 plus 4 L of y is s over s squared plus 4. Now this gives you s squared plus 4. Okay, this you can combine these two. Okay, you can combine these two. This s squared L of y and 4 L of y, it's factored here as s squared plus 4 L of y equals s over s squared plus 4. Divide both sides by s squared plus 4. You have L of y is s over s squared plus 4. Okay, and okay, remember that the inverse of s over s squared plus a squared squared is t over 2a sine at. It was shown in the table. So your y is here. If you solve for y here, okay, there, your y is the inverse of s over s squared plus 4 squared. Where your a is what? Your a is 2. So therefore, your y is, okay, where you get this 4, this 4 is the same as 2a, that is 2 times 2. So that is 1/4 t sine of a sine of 2t. So this is your what? Particular solution. Okay, let's have another example. Okay, solve y double prime plus y is what? Plus y equals t, y of 0 is 0, and y prime of 0 is 2. First step is get the Laplace transform of both sides. So you get to get the Laplace transform. Okay, the Laplace transform of both sides here. So you get what? Laplace of y double prime plus y is Laplace of t. Alright, distribute the Laplace transform. You have what? Laplace of y double prime plus L of y is L of t. Now use the formula for L of y prime of y double prime, that is s squared L of y minus sy of 0 minus y prime of 0 plus L of y, the Laplace of t is 1 over s squared. Now you can substitute the value of y of 0 is 0 and y prime of 0 is 2 here. So you get what? S squared L of y minus s times 0 minus 2 plus L of y is 1 over s squared. Or you can combine what? Actually, you can combine the s squared here. Okay, you have s squared. Okay, you factor L of y here, L of y and L of y. And then of course this is 0. That's why you have what? That's why you have s squared plus 1 L of y equals, transfer the 2 to the right side. You have 1 over s squared plus 2. Combine the right side. Combine the right side, that is s squared as LCD, s squared divided by s squared. Okay, times 1 is 1, s squared divided by 1 times 2 is 2s squared. Divide both sides by s squared plus 1. You have L of y is 1 plus 2s squared over s squared times s squared plus 1. And therefore, y is the inverse of 1 plus 2s squared over s squared times s squared plus 1. Now we'll have to need partial, okay, we have to decompose this into partial fractions. Okay, so you get what? 1 over 2s squared over s squared times s squared plus 1 is a over s. That is what? Partial fraction for s squared is that a over s plus b over s squared plus the partial fraction for s squared plus 1 is cs plus d. Next step is multiply this. Okay, multiply this by s squared times s squared plus 1. Okay, that gives you what? Just 1 plus 2s squared is equal to as times s squared plus 1 plus b times s squared plus 1, okay, plus cs plus d times s squared. Now simplify. Okay, this is the same as as cubed plus as plus bs squared plus b plus cs cubed plus ds squared. Now notice that you can combine all the what? All the s cubed. So for all the s cubed here, a and c, therefore your a plus c, there is no s cubed on the left side, therefore a plus c is 0. For s squared, you have 2b plus d, that is b plus d, okay, is equal to 2 here. So that is equal to 2. That's the second equation. For s, now you only have one s, as, okay, you have as and then what? As and there is no what? There is no s in the left side, therefore a is what? A is 0. Okay, and what about the constant? Okay, what is left is what? What is left is the constant. The only constant here is b. Therefore, b is equal to 1. So we have what? We have b is equal to 1. So here, b is equal to 1. Now, if b is equal to 1, okay, then substituting it there, what is the value of d? 2 equals what? 2 equals 1 plus d. Therefore, d is 1. We now have a, d, and c. What else? And then, what about b? Okay, of course, let's summarize. Our a is 0. Our a is 0. Our b is what? Our b is 1. Our c is also 0. And our d is what? Our d is 1. So here this, okay, our partial fraction now is our a is 0, therefore this is just what? 0. Our b is 1, so this is 1. Our c is 0, so this is simply 0. And our d is 1. So therefore, okay, the partial fractions of 1 plus 2s squared over s squared times s squared plus 1, okay, is simply what? 1 over s squared. Okay, this will cancel out, plus 1 over s squared plus 1. So therefore, your y is this the inverse now, is the inverse of 1 over s squared plus 1 over s squared plus 1. Obviously, what's the inverse of 1 over s squared? That is t. And the inverse of 1 over s squared plus 1, that is sine of t. So therefore, our general solution is, or rather, particular solution is y equals inverse of 1 over s squared plus inverse of 1 over s squared plus 1. That is what? T plus sine t. So this is the solution, y equals t plus sine t.